Great.
Sure.
Yeah, okay, thank you, Diego. So yeah, as Hisham introduced, I'm an assistant professor in quantity surveying at Heriot-Watt. So I've used system dynamics and systems thinking in my doctoral research, and I currently work with some students who are undertaking research um, in construction project management, but they're using system dynamics and systems thinking. So that's the reason why I kind of agreed to do the presentation. So I'm assuming that most of the participants here are students. There could be some experienced modelers as well, but I'm trying to go through the basics of system dynamics and systems thinking as an as a framework for doctoral research. Particularly, I would want to talk about the data collection techniques, data collection methods, and the analysis techniques that you can use in your research. So I've only got like 45 minutes for the session. So just in case, if you want to contact me for any further, questions or anything like that, you can just write to me. My email is there. Um, right. So I'm going to talk about the basics of system dynamics and systems thinking, and also how we use that as a research framework for analyzing or understanding complex problems. I will also take you through the main stages of the system dynamics modeling process. Okay, and also I'll talk about data collection techniques that you can use for system dynamics models or systems thinking in your thesis, right, or in your doctoral work, and also how we analyze qualitative data and also quantitative data, how we use them to build system dynamics models, and also in general in systems thinking. So I've got three textbooks that I really like you to read. Okay, if you're very interested in the field of system dynamics or systems thinking. So the first one is Business Dynamics, written by Professor John Sterman of MIT. So that's kind of the Bible for the system dynamics, the field of system dynamics. And there's another book, Strategic Modeling and Business Dynamics, written by Professor John Moorcroft. So that's also another book that you can refer to. And if you just want to know more about systems thinking in general, I would recommend you read Donella Meadows' Thinking in Systems book. That will give you adequate understanding of what systems thinking is and how we use that to understand complex problems. So when it comes to complex problems, you might wonder what are complex problems, right? So complex problems in general, you can it's a problem that you kind of see everywhere, but you really need to understand the problem before you attempt to solve the problem. Okay, so that means if you ask 5 people, they will have 5 different definitions for that problem, and also they will have five different solutions for that problem. Okay, but with a simple problem, you might have a tool, you just solve the problem. Okay, but with complex problems, so for example, climate change, we can consider that as a complex problem, right? COVID-19 pandemic, and that's a complex problem, right? So we always need to think about the cause and effect relationships, and also there could be multiple solutions for that problem. But the first thing to do is you kind of understand the problem, and for that you might actually want to use um, a holistic approach that can give you the whole picture. So I've used an example here. So the environmental crisis we face now, if you ask 4 people, right, so they might have different opinions on it. They will have different definition for that, right? So I've got a classic example here, 4 blind men trying to understand what an elephant is, right? So they might not even see the problem, but they will try to define it the way they see that, okay, or the way they feel it, right? But with complex problems, you actually can't solve the problem, or at least alleviate the problem, until you understand the problem. That's where we need to use holistic approaches. Okay, so system dynamics and systems thinking are such holistic approaches that we can use. Okay, so with a linear approach, that means you see a problem, you have a tool, you just solve it. Okay, you identify the factors that are affecting the problem, or that are causing the problem. You just solve it with your tool. But for complex problems, you have the problem, but there are multiple factors that are interconnected with that problem, and you can't actually solve the problem until you really understand it. Okay, so that's where we use systems thinking. And most of the times, these problems, they are dynamic. That means they change over time. Okay, so systems thinking basically is an approach where you use a holistic view instead of just partially looking at individual elements or individual components. Okay, so we kind of use a mapping technique that can illustrate the problem, and then we can understand the structure of the problem. So we need to map the linkages, right? So using causality, or using cause and effect relationships, okay? And then we need to create a shared visual diagram, right? So that's the idea behind the use of systems thinking to understand complex problems. And then we can think about any further actions to reduce the damage, or reduce the severity caused by the problem. And we can also identify leverage points where we can intervene in the system, or in the system that creates that problem. And then we can think of any policy changes to implement, or to successfully alleviate the problem, the complex problem. Okay, so that actually takes time. These problems, they change over time. They are dynamic. So you need holistic approaches, such as systems thinking or system dynamics. So I'll just go. I'll just talk a bit about the definitions that we have for systems thinking. You might actually wonder why, or what systems thinking and what system dynamics is. Okay, so systems thinking is preliminary a soft or a qualitative approach, I would say. That's at least what I see that as. So one definition we have is scholars, they say systems thinking could mean systems science. So that means any holistic approach that you normally use to identify or analyze a complex problem. The second definition says systems thinking means soft systems methodology. Again, there are certain tools that you can use to map the complex problems. The ones that I've shown here on the upper right corner. So those are known as soft tools, soft systems tools you can use to analyze or understand the complex problem. But then again, the third definition, which I am familiar with, it says systems thinking means the qualitative phase of system dynamics modeling. So what system dynamics modeling means, in addition to just mapping the complex problem, we consider analyzing the behavior of that particular system, okay, of the problem, and we analyze the behavior over time. That's where the dynamics happen. Okay, so we need to understand the causal mechanism behind the problem that lead to this problem. Okay, and we also need to think about what feedback mechanisms are involved creating this problem, right? So we always think about causal links and feedback loops and stock and flows. So we need to guide policy structures that can alleviate the problem. We can test policies. So basically it involves simulation. So we consider system dynamics as a hard or quantitative approach, but then again, it also has certain qualitative elements attached to that, because we first need to brainstorm ideas and understand the structure of the problem, the system itself. So that's where the third definition and system dynamics would act together. So I've got some very few examples, I would say, that people have applied system dynamics or systems thinking in their work. So starting from my preferred area of construction, and then you move on to social problems such as the Mexico's cartel problem, homelessness in the US, and also states of child protection activities. Again, you kind of they have analyzed the functionality of rural water services in developing countries, healthcare or health promotion in the Australian healthcare system, and recently we had the COVID-19 pandemic. So these are just very few examples that people have used. People have applied system dynamics and systems thinking, and you can find hundreds and thousands of different applications of the two methodologies. Okay, in doctoral research and also in practice. So system dynamics is a field that's in practice in the industry as well. So you could actually go through a lot of different examples. You can go through a lot of a different application of the two methods. But I'm kind of referring to system dynamics and systems thinking as the qualitative phase of system dynamics modeling. So again, when you talk about the system dynamics modeling process, it involves a qualitative phase and a quantitative phase, right? So in the qualitative phase, you should be able to identify the problem, and you need to formulate a complex dynamic problem that is causing that requires a change of the policies that you currently have. And then you also need to identify the key variables or key elements or key factors that contribute to the problem. And then again, you need to think about the feedback structures, right? So that's where you actually map the system or the problem. So one thing to remember is when it comes to systems thinking or system dynamics, in that matter, you always model the problem, or you always illustrate the problem. So the system that drives the problem will once you model the problem, the system structure that drives the problem will give you the holistic picture of the problem, right? So again, you need to identify the cause and effect relationships between the variables, and you need to draw causal loop diagrams, right? The feedback loops and things like that. And then we move on to quantitative part, which is the actual dynamics, right? So in that phase, you would always need to convert your causal loop diagrams into stock and flow diagrams, because stocks and flows are the ones that drive the dynamics of the problem of the system. So we need to identify the accumulations and rates of change within the system. So, for example, if you take a bathtub, that's the stock. That's the water in the bathtub. It's the stock, and then you might have two valves, one inlet and one outlet that can control the water coming in, and the water goes out from the bathtub, right? So those are the flows, or those are the rates of change that control the stocks. Okay, and the important thing in system dynamics is we need to somehow express the cause and effect relationships using mathematical or differential equations. Okay, so we have to use certain software for that. For example, Vensim or AnyLogic or Stella. So those are commonly used software for that. And then obviously you need to simulate the problem, right? We need to analyze the model behavior over time. And then you need to think about validation of the model, right? You need to do certain tests. So you might need to compare the real and the simulated scenarios, the behavior, the model structure. And then you also need to think about testing policy alternatives. That's why we actually use a system dynamics or systems thinking, because we don't need the current state of the policies that we have, and we need to go and look for policy alternatives so that you can apply them in your current system, and you kind of change the state of the problem, or alleviate the severity of the problem, right? So, and then obviously in real life you might want to implement changes that can alleviate the problem. So starting from a qualitative phase into a more quantitative phase, and then you kind of analyze the model behavior over time. So that's what usually involves in system dynamics modeling process. And if you go through the literature, different people they explain the modeling process in different ways, right? So in my example, in this session, I've chosen the process explained by Randers. Okay, so that's conceptualization. That's how you understand the problem, and then how you formulate the problem, and then you have testing phase where you kind of test the problem, right? And then you implement the policy changes. Okay, but again, other scholars, so such as Sturman and Wolstenholme, so they have different explanations, or they have proposed different processes, but it's going to be more or less the same. I have to say that for beginners who really are newbies into the field of system dynamics, right? So you start with the problem, you create the dynamic hypothesis, where you kind of hypothesize the structure of the problem that leads to a certain behavior, and then you kind of formulate the stock and flow diagrams. You do the simulation, and then you kind of test new policies, right? So that's what basically involves in the system dynamics modeling process. So for doctoral researchers, choose whatever the process that you kind of you are kind of comfortable with, right? But in my research, I've used Randers 1980 process proposed by him, and also I've used Professor Sturman's process as well. So what actually system dynamics does is you first start with formulating the problem, right? And then you kind of develop that into a set of feedback loops, or causal loop diagrams, we call that. So the connections are based on the cause and effect relationships, not correlation. You have to remember that again. And then once we have the causal loop diagram, we kind of develop the stock and flow diagrams, and finally we do the simulation. We go through the behavior over time, but this is an iterative process. Okay, so it's not like you first do the causal loop diagrams, and then you do the stock and flow diagrams, and then do the simulation, and then call it a day. It's not going to happen like that. So what happens is you go back and forth. You kind of improve the model, you improve the causal loop diagram, and you improve the stock and flow diagrams. You run simulations, you change scenarios, you change parameters, and then maybe try changing. If you have any errors in the model, you might need to change them as well. Okay, so this is the typical. These are the typical tasks or activities that are involved in the process of developing a system dynamics model, and that leads to a simulation. So the main part that I want to cover today is the data collection techniques that are available for doctoral researchers who are using system dynamics and systems thinking. So when it comes to problem definition stage, that's where you kind of understand the problem, right? You kind of define the problem that has to be examined, right? So we call system conceptualization, right? That's where you start collecting data. That's where you start going through the literature. That's where you start talking to people, right? And I've mentioned here accessing mental, written, and numerical databases. So the important thing about system dynamics and systems thinking is we always believe that the mental database, right, the mental models created in people's mind. So that's the richest database that you can have, that you can extract cause and effect relationships. That's how they explain the structure of the system. That's how they explain the model itself, right? So in order to access the database and extract variables, right, you need to use qualitative data collection techniques such as interviews, focus groups, could be Delphi groups, or even participatory or group model building workshops, where you actually get people to you act as a facilitator, and you kind of ask participants to build a model, right, who are involved in the system. And also you can refer to a written database as well. So in my research, I found newspaper articles to be really valuable. And then also you can, if once you've done the interviews, you can also use interview transcripts or focus group transcripts as written database. You can also go through reports, internal memos, letters, even emails and things like that that contain information about the problem and investigation. So for researchers, for doctoral researchers, even for master's students, I think the important thing is to remember is you don't get the PhD without data. So it's always good to use a range of different types of data. So you can incorporate interviews and also newspaper articles or reports and things like that. And also, in addition to the mental database and written database, we obviously have a numerical database, which is going to be published statistics, economic or financial quantitative inputs, primarily for simulations, right? But if you see the diagram at the very end, just this one here, so you can see the mental database contains the richest data that you can extract information on the structure of the system, right? And then the numerical database has the least amount of data for structuring the problem. That might actually give us enough information to run a simulation, but it won't give us the structure of the system or the problem that we are trying to understand or examine. So model formulation stage is where you actually document the data that you collected, and also it involves analysis of data. One thing to remember is both the data collection and the analysis of data will involve at every stage of the modeling process. It's not just the problem definition stage, or it's not just the formulation stage. You still need to collect data until the very end and analyze that data and use that data in your models, in your simulation, right? So in the formulation stage, that's where we kind of extract the cause and effect relationships. That's where we go through the data that we've collected, and we try to identify cause and effect relationships. And we build the feedback loops or causal loop diagrams, and we explain the causality. And then again, you can use interviews to elicit the model structure. You can also think about the current policies and the policies that are required to change the state of the problem. And also you can extract parameters. You can get parameters from for the simulation from the individuals involved in the interviews. Same thing you can do with focus groups and Delphi groups as well. Instead of focus groups, you can also go for a group model building or participant observation workshops. That's where you get involved with the actual stakeholders or the actors involved in that particular problem, right? And then you observe the model. You ask them to observe the model structure. You can even ask them to build the model. You can do some workshops with them and identify policies and the changes that you require. And then again, you can identify data or parameters or values to run the simulation, right? So at this stage, this is mostly a qualitative stage that you deal with qualitative data, right? So in terms of analyzing data, you might actually use some of the very commonly used data analysis techniques in qualitative research. So you can use thematic analysis to identify the key variables or key themes and the underlying causality, right? And also you can use grounded theory, which is one of my favorite methods or methodologies, I would say, because you can actually frame your research and the contribution to knowledge as a dynamic substantive theory. Grounded theory usually results in substantive theories. So the model that you build could be framed as a dynamic substantive theory that explains the underlying causality behind the problem that you are analyzing. So that involves coding of data, identifying cause and effect relationships again, and then explanations on causality. So for PhD researchers, I would recommend you use either thematic analysis or grounded theory in the concept in the formulation stage. So that's where you develop the causal loop diagrams, but also not just the causal loop diagram, but you also understand the model structure. You identify the cause and effect relationships, which is really important. Again, you can use content analysis primarily for documents, right? So you can identify parameters for simulation models that you're going to use in your research. So I've got some examples. So this is an extraction of variables and causal relationships from interview data, right? This is an example of that. So as you can see here, they have different themes. They have identified different themes. So years in business, industry connections, and then they note their observations. And something very important for system dynamics modelers or even systems thinkers, I would say, you always need to ask the question why this is happening or why this is interesting. That's where you actually generate the cause and effect relationship, and then you kind of ask the question why this is relevant to the system dynamics model or systems thinking approach. You can also think about emerging theories, and you can also record any missing data that you require to build the models, right? And at the end, you kind of have the identified variables or codes, you can call them, right? And then the causal links, right? So if there's whether there's a positive relationship or whether there's a negative relationship, things like that. So you can use that to build a causal loop diagram like this. It's from the same article. Okay, so these causal links, the variables, they have put them in order, and they've created a feedback loop using those variables. Okay, so you might see plus and minus signs. For beginners, I would say this plus sign denotes a positive causal relationship. That means when the workforce size increases or decreases, labor cost will increase or decrease in the same direction. Okay, and then again you have a minus sign here. So that's when the that denotes an inverse relationship. So that means once the labor cost increases, the business profits might decrease. And then once the labor cost decreases, the labor profits might increase. Okay, and then with that information, if you have enough information to build a stock and flow diagram, you can also use the software to build a basic stock and flow diagram. That's where you actually use mathematical equations, and that's when you run the simulation. Okay, so here the workforce size is a stock. Okay, and hire and dismiss, they are flows, so they are the variables that you can change. Okay, so whenever you change the hiring rate or rate of hire, you might change the workforce size. Same thing with the dismissal rate as well. And another example using Delphi groups. Again, in this case, what happens is you use certain participants. You have a panel of participants, and you ask them to analyze a situation or a problem, right? And then give their opinion on that. So based on their explanations, you can put them in a coding chart, like the one on the left. Okay, and then you can start developing the model, right? So it might actually involve several rounds. Okay, in the first round, they have a simple causal loop diagram. And then in the second round, they kind of add more feedback loops into that. And then again, in the third round, you kind of add another set of variables, another set of feedback loops into that. And then finally, on the fourth round, they will actually complete the causal loop diagram. Again, this is something that I would highly recommend for the PhD researchers. Okay, so it's not just to build the model, but also that involves collecting data and analysis of data, which will give you a good experience on using Delphi groups as well. Okay, so and then the other one that I want to show you is the group model building workshops. Okay, so basically you kind of get involved with the actual actors or the stakeholders of that particular problem or the system under investigation. So you kind of ask them to define the problem, right? And then you kind of have workshops or interviews with them. You ask them to build the model by themselves, right? Draw the causal loop diagrams, and then you kind of extract the cause and effect relationships from that, and then finally you can move on to developing the stock and flow diagrams and the simulation stage. So one of the analysis methods that I would recommend you use in your research is grounded theory, right? So that actually involves development of substantive theories that can be applied to a specific problem or specific context. Okay, so that involves coding, right? Different levels of coding, open coding using raw text data, right? And then you kind of go through the main concepts, main themes. You then move on to axial coding, where you kind of have the list of themes, and you kind of categorize and aggregate themes into variables that you can use in a causal loop diagram. Again, when you have the coding chart, the coding tree, like the one you have on the right side here, you can think of the use of causal relationships, or the link polarity, I would say, whether it's a positive or a negative relationship, right? Always link that to the data that you have collected. Okay, so once you've done with that stage, I think you can extract the variables and create the substantive theory. That's what I would like to call it, or the causal loop diagram, or the systems map. Okay, so this is actually a static substantive theory, because that doesn't involve any simulation or stock and flow diagrams. But for system dynamics modelers, I would say convert this into a diagrams, and then you can call it, or you can frame your research as a dynamic substantive theory. Okay, I'm not sure how much time I have, so I'll quickly go through the rest of the slides. Okay, so testing stage means that's where you actually develop stock and flow diagrams. Again, that involves data collection and also analysis. Okay, at this stage, you might actually want to think about the policies, right? The policies that you want to implement, the policies that you want to be changed in your system or in your model, right? And you can extract parameters from individuals, the values or the values you use for to do the simulation, right? You can also obtain expert judgment from about the model structure, the model structure and behavior. Okay, and then same thing you can do with focus groups and Delphi groups as well, right? Again, you talk to the stakeholders, you have a panel of experts, or you have a group of actors involved in focus group discussions or Delphi groups. And then you can also ask the participants from who are part of the problem to observe the policies and maybe give insights into use the values or the parameters for the simulation. At this stage, you can also use surveys, I would say, because you might need quantitative inputs for the simulation models. Okay, so a questionnaire survey would do that, and you can actually extract parameters or values for simulation models using surveys. You can also use secondary data or published statistics or time series data that will give you enough parameters and values for simulation models. Okay, and then data analysis obviously involves simulation. That means we kind of observe the behavior over time, right? We might need to go through different scenarios, different possible scenarios, and also you need to test policy alternatives to change the state of the problem. You might also need to think about model calibration and validation of the model. That's very important. Okay, so you build a model, which is obviously wrong, right? Because according to Sturman, every model is wrong, but some models are every model is wrong, but some models are kind of useful. Okay, so you might need to think about the model boundaries, right? Whether you've included every variable, and are there any variables missing, or are there any variables to be removed? Okay, you might need to think about the structure of the model or the system. Okay, and then how that might perform under extreme conditions. Okay, so you might need to change parameters and see what happens there. Also, you might need to think whether this can be replicated or this can be used in a different scenario as well, right? Whether the behavior of the model can be reproduced. Okay. Again, you can use model validation tests that are available that we normally use in system dynamics modeling. So if you refer to John Sturman's book, I would say that will give you enough information about the model validation tests. But also, in addition to that, you can also use expert judgment as a way of validating your model, right? So instead, you can still use model validation tests, on the software itself, but you can also talk to expert system dynamics modelers and ask them to verify the model structure and things like that. So they might be able to give you some good insights into that. So yeah, what happens with stock and flow diagrams is you kind of convert the cause and effect relationships, or you express them using differential equations, mathematical equations. So we consider stocks and flows for the simulation, right? So, and then you kind of have the model behavior over time, means the simulation part. Okay, and you might need to use certain software like Vensim or any logic or Stella, right? So those are the typical software packages we normally use to run simulations. And also I talked about expert judgments, obtaining model parameters from the experts. So you can use this as quantitative data to run your simulation, right? So instead of you just randomly giving values, values for the variables, you can ask the actors who are involved in the system or experts who know the subject area to identify units, and you kind of identify the values to run the simulation, right? So that's also one possible way of integrating quantitative data in your simulation model. And then the final section I want to show you is the scenario analysis, which involves testing different scenarios, or kind of analyzing different possible alternatives. Okay, so and then you can obviously do certain validation tests to check the consistency of the model, the structure of the model, and things like that. So I think I'm on time right now. I've exactly used 45 minutes, I think. So yeah, so that's all what I wanted to share today. So I'm happy to answer any questions you have, or even if you want to contact me later, I can. I'll be more than happy to get in touch with you. Thank you very much.
Thank you, Giman, for keeping things right on cue. So thank you for the excellent presentation. We have a couple of questions from the participants. The first question was about regarding how many time points of data do you need to run a simulation? Is there a minimum?
Can you repeat that question?
This is Nicholas Wash. He asked the question: how many time points of data do you need to run an assisted dynamic simulation? Is there a minimum?
No, I don't think there's a minimum. I mean, there's no minimum or maximum. I would say it depends on the area that you're working on and the problem that you're trying to analyze. Yeah.
Yes, please.
Can I just follow up? So I'm interested in health and behavior, and sometimes there's these longitudinal surveys where they collect data on cohorts every year or every 2 years, and there's only like 3 or 4 maybe data points, with these questionnaires. And I just wondered if it was possible to run a system dynamics model using that type of data, or whether there needs to be more frequent data. That was just like that.
Yeah,
but thanks again for the really excellent talk.
I think it's possible. Yeah, I think it's possible. I mean, you might not get the same data like and the second time you do the survey, and then maybe on the third time you do the you collect data. So yeah, you can run different, you possibly run a simulation or scenario analysis, I would say, and then check whether you're able to do that or not. Yeah, I would say yes. And thank you, David. I think you corrected me there. So all models are wrong, but some are useful. That's George Box. But I actually found that on Sterman's book.
Yes. There's another question from Derek on developing dynamic theories. He has 2 questions. He's noticed that instead of using grounded theory, some scholars have used case study design. as opposed to grounded theory. Can you please talk about
yeah,
that? Yeah.
So Hisham, I think, I mean, if I can just relate to that, because I also use case study based research design, but I used grounded theory within that. So as the data analysis method or methodology, but sometimes grounded theory is purely used as a methodology, not just as a method to analyze data, because that involves continuous data collection and and analysis, and then you kind of go back and then you collect data, you code, and then you go back again, you collect data. So it's possible, yeah. So both case study and grounded theory would work together.
Derek, would you like to ask the second question yourself?
Hello, sorry, can you hear me?
Yeah.
Yes, we can.
Yeah, thank you very much. Yes, I certainly agree with what you have said, because if the paper that you showed us by Eka and Zimmerman, although they were, my take was that although they were refining a grounded theory method by Kim, on the paper they actually say they're using a case study. So maybe they actually integrated the truth, or I agree with that. Maybe I could also ask my second question.
Okay.
It's already in the chat. I asked, you said you need to simulate to make them dynamic theories. But I've seen dynamic theories that are done qualitatively. They don't simulate, but they're still called dynamic theories. Some of them have studied with, in their analysis or in the dynamic report, they've studied with a generic structure. So it's a starting theory, and then you can expand.
That's right. So you can also refer to, I mean, I haven't mentioned that, you can also refer to system archetypes. So that's kind of the reference or like the generic feedback loops or the model structures that you can see when you develop system dynamics models, or even system thinking, of course, loop diagrams, I would say. So you can also refer to them as well, and then compare your results or your model structure against the system archetypes as well.
Yeah, thank you very much.
Yes, thank you.
Thank you.
We've have some very good suggestions by David Lane in the chat. David, would you like to say a few words as well?
No, it's not my talk. It's this gentleman's talk, and he's done a lovely job of it. So no, I've just been trying to support it. No, but thank you.
Thank you very much for sharing the references in the chat.
Yes, thank you very much. And if anyone wants to, get in touch with me, you can just drop me an email. I'll be more than happy to answer your email. And also, if anyone wants me to join your research or work with, contribute to your research in system dynamics or systems thinking, I'll be more than happy to do that as well.
We have a last question before, because Gimham, I realize you have a meeting at 10. The question is there agreement in the field about system archetypes?
So I would say if you refer to the work of Donella Meadows, so I think she has developed certain system archetypes she has identified, and Lane as well. So there is an agreement, I would say.
Okay. Thank you everyone thank you Gimhan for sharing the presentation. We're gonna stay on. Gimhan has to, of course, go for a meeting at 10. If anyone has any further questions for Gimhan, we can forward it to him. There's his email address as well. We'll provide the presentation as well as the video on the link on System Dynamics, UK System Dynamics website, as well as the TRANSCEND website. So we'll share those links with you as well. Thank you, Gimhan. Thank you very much.
Thanks very much, everyone. Thank you, Hisham. Thank you. Yes, see you guys.
If anyone wants to stay around and talk about the UK System Dynamics Society, especially the student events that we're planning, please stay around and talk to us, especially the conference that's coming up. And if you want to present something next time, we'll be interested. Get in touch with us as well. We'd like to continue this process of sharing, our system dynamics experiences with the student, generally the students and those who are interested in applying these methods. Would anyone like to say anything? Or Diego, can we share the screen on the System Dynamics Society?
Sure. Yeah.
Conference? Yeah.
Yeah, I just shared the link on the chat if anyone needs it. But yeah.
So this is going to be a hybrid conference. I'll encourage everyone, if they can, to attend the first day of the conference, which would be online. Nicholas, do you still have a question? I see your hands up.
Yeah, hi there. Sorry, I haven't got my camera on.
Yeah, no worries.
I've got some students who are keen to do this type of system dynamics approach. I'm a psychologist at University of East Anglia, and I've never used system dynamics before. And it's just a bit overwhelming, really, like where to get started. And I wondered if it's kind of, I don't know, just get some support and work with engineers and develop these ideas a bit. Like how to go about that.
Yes, that's one of the reasons for for the UK Systems Dynamics Society and the International Society. When you join the society, even on our website, we have a lot of resources that can be used for newcomers and beginners. For one, your students are welcome to join us at the System Dynamics student chapter, where we can share our experiences and how we started and how we are getting into the field. And of course, part of the conference we talked about on day one, on Thursday, the first session is going to be an introduction to system dynamics by Kim Warren himself. And I encourage them to join if it's possible for them to join the conference. Kim Warren has also the link shared by Diego, has shared that link. Has a free course, which is a really intensive course on system dynamics and applying it into business and decision making in business organizations. It's a really good course. If you're interested, you can have a look at that. Yeah. And there's also, of course, on the System Dynamics Society, there's a lot of links to free online courses. Like I remember there's a Coursera course for public health. I'm not sure if it's relevant to you or not.
Definitely, yeah.
So there's a Coursera course. I think the Johns Hopkins University does a free course on public health. I'll share the links to that as well in the chat. But if anyone else has suggestions, David Lane has suggested the Bible for System Dynamics right there, and other things. Please feel free to jump in and recommend what you have used, to get into System Dynamics or an introduction wise.
Thanks so much.
You're welcome. Diego, did you want to say anything?
Yeah, no, I just saw a question from the Dr. Ali L.S. Sawi. So what are the main UK universities specializing in SD? So I guess, there are like many of them out there. There are some that specialize in certain fields. I know there are some that look into construction. There's a lot of applications in terms of construction. There was some. There are some interesting applications, but I don't think that anyone specifically is like focused on a specific field. There are like a lot of them. At least, for example, some of the Welsh universities specialize a lot on healthcare. That's what I've seen. I don't know, Hisham, if you have any other.
Well, I'm like Gimhan himself was from Heriot Watt. I think Heriot Watt's construction management department or that faculty has a strong system dynamics sort of like presence in that department. And there are some business schools that use system dynamics. But I'm personally, I would imagine from what I've heard, so Heriot Watt has a few people contributing to system dynamics. Strathclyde has a strong, I think it's I'm not sure which department, which faculty it is, but they have a strong system dynamics presence. I mean, I'm sure there must be someone at I remember Brian Dangerfield was at Salford, but he's now at Bristol, but I'm not sure. I mean, we'll have to check that, but there are a couple. And I mean, David Layden's on this chat as well, so he probably knows more about where who's working on what where. Yeah, and anyone else? Does anyone else have any questions or suggestions, perhaps, or maybe experiences to share? So yeah, so just to keep in mind, the conference is coming up on April 21st, 22nd. Is that right? Yeah. And the first day will be online, so it's a hybrid conference. So the first day we will try to bring in the events to an online audience for those of you who will not be able to attend it, and those who are able to attend it. It's in Strathclyde, and I really recommend the Kim Warren session, which he's asked us to dip into his course first before coming to that session. So if you have any questions, you'll be primed to answer those questions. So it will be a good primer for you in system dynamics overall, as such.
Yeah, there's a question about if we know any SD groups focused on crime prevention or organized crime. I think, in that sense, I think the International System Dynamics Society has some research groups. They've done a lot of work finding people that are specialized, and there's like even peer groups, right, Hisham? I think there are some peer groups that focus called, on specific areas.
Yeah, the International Society has a thing called special interest groups, SIGs. And these special interest groups focus on specific topics. So there's one on, for example, economics. There's one on, security issues. There's one on, I think I don't know if there's one on crime prevention or organized crime, but it's worth looking at the System Dynamics Society's website because they have a list of all the chapters and all the SIGs, all the special interest groups. And then from there, you can actually see one which, there might be close to either crime prevention or organized crime or something of that. But I personally don't know of any, but I'm sure there must be some related in that direction on the website.
I shared the link so you can check them out. The special interest groups. Yeah, we worked a lot with the International System Dynamics Society because they had done a lot of work, and especially because they have a farther reach, I guess, in terms of the geographies. So sometimes we go to them.
Yeah, so I just shared the Systems Thinking in Public Health, a free course, which I'm aware of is really good. Yes, the Systems Dynamics Society, the International Society, has a very good sort of like a website where they actually tell you of a lot of free courses as well, where they're available and if they're free or not. So it's a very good resource for newcomers.
Yeah. Yeah, I think also in propagation analysis, you might have to go. That might be more specific. You might have to check it.
Propagation analysis, as in you mean like cascading effects?